All right, welcome back. And now what we're going to do is we're going to talk about polynomial functions. I mentioned that in a previous video when we were talking about quadratic functions. Quadratic functions is also an example of a polynomial function. So this is a family of functions. And so let me give you an example where this comes up. So it says, in this example it says, a solar oven is to be made from an open box with reflective sides. Each box is made from a 30-inch by 24-inch rectangular sheet of aluminum with squares of length x inches removed from each corner. Then the flaps are folded up to form the open box. Okay, so we're talking about something that looks like this, right? So we have our rectangular aluminum foil or an aluminum metal, and what we're going to do is we're going to cut out from each corner a square, and the length of the side of our cutouts are going to be x, and then what's left over is going to be the flaps that are going to be bent upward to make our box that is going to be used for a solar oven. And so if you take that example and calculate the volume of the box, right, you would get this polynomial function, right? And so what we're going to start doing is we're going to this section is going to be all about understanding polynomial functions and how to analyze and graph polynomial functions like this one. Okay, so now the definition of a polynomial function is given as follows. It says let n be a whole number and let n sub n a sub n, a sub n minus 1, a sub n minus 2, and so on, all the way down to a sub 1 and a sub 0 be real numbers, where a sub n is not equal to 0. Then the function defined by f of x equal to a sub n times x to the nth power plus a sub n minus 1 times x to the n minus 1 power plus all the way down to a sub 1 times x plus a sub 0 is called a polynomial function of degree n. Okay, so now notice how this is called the leading term. This is the leading term because it has the x variable with the highest power. Okay, so the term that has the x variable with the highest power is called the leading term. Okay, the degree of the polynomial is based on the leading term, the exponent of the leading term, and the coefficient a sub n is called the leading coefficient. Okay, we're going to talk more about that later. Okay, but this is the definition of a polynomial function. So notice how down here we have f of x equals 4x to the 5th minus 3x to the 4th plus 2x squared. So this is an example of a polynomial function. Notice how all of the coefficients are real numbers and the exponents are all whole numbers. Okay? Now this down here, this function is not a polynomial function by definition because it does not fit the definition. One, we have a variable here that does not have a whole number as an exponent. It has a fractional exponent because of the root, right? So this is actually x to the 1/2 power. Okay, so it does not fit the definition. So this is not a polynomial for that reason. Also here, another reason we do not have a whole number because this x variable here has a -1 as an exponent. So again, it's not a whole number. Here it violates the definition because the coefficient is not real. That's an imaginary number, or that's a complex number. Okay, so therefore it violates the definition. So the bottom one is not an example of a polynomial function, but the top one is. Okay. Have a great day.